From the perspective of someone on the ground, the sphere will appear to veer towards the east. Therefore, objects moving from the equator to the North Pole will veer in the opposite direction as objects moving from the North Pole to the equator. Suppose we have a low-pressure area, and the air molecules around this area experience a force towards the center. The air molecules experiencing a northern force will veer in the opposite direction of the air molecules experiencing a southern force, causing a rotation. This is the reason why hurricanes rotate counterclockwise in the northern hemisphere and clockwise in the southern hemisphere. All the laws of motion are always riding with us, including the third law. As the helicopter exerts a force on the blades instantly exert an equal and opposite force on the helicopter. This causes the helicopter to want to rotate in the opposite direction of the blades. This is why a tail rotor is needed. The force from the tail rotor can be adjusted to cause the helicopter to turn left or right, or to keep the helicopter pointed in a steady direction. The tail rotor exerts a force on the helicopter by creating an equal and opposite force on the air molecules. This is the same way in which the main rotor creates an upward force against gravity. Birds and airplanes also fly by creating a force against the air. The upward force against gravity is caused by the way the air flows around the wings. Suppose that the air around a wing is standing still. The air pressure from above and below the wing will cancel out, and there will be no net force. As air flows around the wing's shape forces the air above the wing to flow faster than the air below. The air pressure below the wing is now creating a greater pressure than the air above. This creates a net upward force on the wing. This also creates an equal and opposite downward force on the air. Birds, airplanes, and helicopters work by pushing against the air. But this will not work in space, where air does not exist. In space, we need another way to create a force. As the walls exert a force on the particles exert a force on the walls. If there is a hole in one of the walls, then the forces on the walls will no longer cancel each other out. This is how rockets create a force to travel through space. Although the force of gravity gets weaker as we move further away from the Earth, this is not the reason astronauts feel weightless when in orbit. In Earth's orbit, the force of gravity is still very strong. The first law of motion wants Victoria to keep moving in a straight line, and her forward motion is the only thing preventing her from falling directly into the Earth. The first law of motion also wants the box to continue moving in a straight line, and the box's forward motion prevents the box from falling directly into the Earth. Victoria and the box both end up orbiting the Earth following the exact same path. Since Victoria and the box are always moving together, this creates the illusion that she is weightless inside the box. This is the same way in which Victoria would appear weightless if the box were to fall from the sky. This happens because gravity is different from all other forces. If two objects experience the same force, the lighter object will accelerate faster. In the case of gravity, however, gravity exerts a greater force on more massive objects than on lighter ones. This causes all objects to fall with the exact same acceleration, regardless of their mass. Some objects fall faster than others only because of air resistance. Air resistance affects different objects differently. This is why parachutes work, and why feathers fall slower than bowling balls. In space, there is no air resistance, and all objects react to gravity in the same way, regardless of their mass. Victoria and the box therefore follow the same path and stay together. No other force behaves this way. Albert Einstein discovered that there is a profound reason for this. It is because gravitational forces don't actually exist. Here, there is no force, and Victoria is actually still just following a straight line. Objects with mass cause a curvature in space and time, causing straight lines to appear curved to us. This creates the illusion that there is a gravitational force. Different objects travel through the same curved space-time. This is why, unlike all other forces, gravity causes all objects to follow the exact same path, regardless of their mass.